Hello everybody. In this video I'm going to be going over where the derivative of tangent comes from. So just me personally, I love to figure out like where things come from. It helps me remember things really well because I remember the intuition better than like the memorization technique. But that's just for me personally. I hope that this helps you. But let's actually get into it. Where does the derivative of tangent come from? And like a lot of things in mathematics, especially trig, we can kind of figure things out just by using stuff we already know. Um, so hopefully you're already familiar with the derivative of sine and cosine. So let me just write this down so we kind of have uh, our uh, kind of toolbox that we can use for the throughout the video. So we know that the derivative of sine of x is just going to be cosine of x, and we also know that the derivative of cosine of x is equal to sine of x. All right, that's we're kind of switched over. Oh, negative sine of x, negative sine of x, negative sine of x. Okay, I was able to fit it in there. So these are kind of our building blocks. Feel free to watch like other videos to figure out where this comes from because it's always nice to start from square one and see where this stuff comes from. But when we actually want to figure out what the derivative of tangent is, let's think of another expression of tangent. So um, tangent of x, this is also just equal to uh, sine of x over cosine of x, right? Um, Hopefully you learned this in trig when you're going over the unit circle and things like that. Tangent of x is just sine of x over cosine of x, right? So if we take the derivative of this, then we'll know the derivative for tangent. So let's actually do that. Let's do d over dx of sine of x over cosine of x. Okay, so I'm seeing that I have the quotient of two functions, right? So I'm trying to take the derivative of one function divided by another function. So hopefully you have practice with a lot of the differentiation techniques, and from here we can kind of think, oh, okay, maybe I'm going to end up using quotient rule. So real quick, I'm going to just to a bit of a review. Quotient rule states that if I am trying to take the derivative of like f of x divided by g of x, this is going to be the same thing as uh, f prime of x times g of x minus f of x g prime of x, all of this over g of x squared. So this is quotient rule. Hopefully you have at least a little bit of practice in quotient rule. It's okay if you don't, but you'll probably get more value out of this video if you do. So okay, let's apply the quotient rule to this guy over here, right? So the derivative of the first derivative of sine is cosine, right? Cosine of x, and then we're going to be multiplying by the bottom, right? So I'm multiplying cosine of x times cosine of x, right? So I'm just going to write cosine squared of x over here. Then I'm going to do minus my first times the derivative of my second. So it looks like derivative of cosine is negative sine. So I'm actually going to be multiplying this by a negative sign. So I'm just going to change this to a plus sign and a squared like this. Okay. So all I did is I'm multiplying two negatives, so I just changed this to a positive. Hopefully that doesn't confuse you too much. So I have cosine of x squared. Cosine of x squared plus sine of x squared, and then all this is going to be over cosine squared of x, right? Because it's just g of x squared. Okay, so we're near the finish line. This is a pretty short video, but that's okay. So if you are familiar with the Pythagorean identity, just from trigonometry, cosine squared of x plus sine squared of x, that's just 1, right? So that comes straight out of the Pythagorean theorem in the unit circle. It's pretty cool. And then I'm left with cosine squared of x. And you know what? We literally just found the derivative for tangent of x. It's 1 over cosine squared of x. If you look in a textbook, they'll probably list it as secant squared of x, just because it's nicer to think of it as secant squared sometimes than 1 over cosine squared. But we literally just found that the derivative of tangent of x is just equal to secant squared of x, which is pretty darn cool. We were able to find the derivative of tangent by just like figuring out a different expression of tangent. And and then from there, we already know how to do this stuff. We already know how to differentiate sine of x. We already know how to differentiate cosine of x. We know how to do quotient rule just from here. So just using all of our building blocks, we can apply it to tangent, and without even having to like really get too rigorous, we can just go through this part, and then we literally just found uh, a solution for the derivative of tangent. So anyway, this is hopefully you enjoyed. Hopefully this helps you remember that the derivative of tangent is secant squared of x, because you'll probably need it for if you're asked to find the derivative, or maybe you're integrating secant squared of x or something. But anyway, I hope this is helpful, and I wish you luck on your future calculus endeavors. See you in the next one.